Okay, this is the video on how to do Lab 1. Okay, so you are given your objective to implement the 5 different logic gates. Okay, now there are no design specifications for this lab, so we're not designing any circuit, we're just working with the individual gates. Okay, now what are you actually supposed to do? Okay, you are supposed to create, where is it? This circuit diagram. You need to create this circuit diagram, and then you need to create a test bench for it. So where was test bench? Test bench here. Create a test bench for it. Okay, and then what? Your end result is the simulation waveforms. Where are they? Yeah, simulation waveforms similar to this. Okay, so that's your objective in terms of practical things that you need to do. All right, so there's a video on how to do this. Okay, so that's this video, QuartusSimulationLab1. You'll play this video to help you to complete the lab. All right, now, did not mean to do that. So I have that. And now I have extensive documentation on how to use the software, both detailed and summarized, under Lab Help Quartus documentation. So I have a document there that guides you step by step with screenshots on how to use the software. Then I have other ones that are in summary form, such as down here, where you don't have the screenshots. So once you're familiar with using the software, you only need summary steps. Okay, now, you need to do what's called a demonstration to show that your lab works. Now, when we had the lab classroom, you would call over the instructor and show the instructor that you got the lab working by showing him the waveforms. Okay, and maybe showing the schematic too. Now, for us now, we don't have that classroom, so your schematic and your waveforms constitute your demo for your lab. Okay? By looking at those, I can tell if you did the lab successfully. I can see if you got the schematic correct. I can see that you got the waveforms correct. All right. Okay, so there is a lab report you have to write on this. So doing the lab involves producing a demo, okay, which is now in the report. It used to be live demo. We don't have live demo. And you also have to produce a report. So there's a sample lab report on Canvas where you have a procedure that you went through to complete the lab experiment. Now, when you get the procedure, and we'll talk more about how to do the lab report, I'll go over the sample lab report in another video. For procedure, don't give the steps for running the Quartus software, which are down here. Give the design procedure. Now, in your case, for Lab 1, you don't have a design procedure. So Lab 1 doesn't have anything to design. So your procedure involves placing components or labeling inputs and outputs. So again, in your lab report, make sure to include a screen capture schematic as well as the waveforms in the results sections of lab report. Also explain below your waveforms what the waveforms should show or prove or how they validate the correct operation. Okay. So that covers what we have to do. Okay, so we will begin doing the lab. So the first step is to open the software. So you will find the icon here that says Quartus Prime 18.1 Lite Edition, and you will right-click on it and run as administrator. Okay, for me it's opening fairly quickly this time. Okay, now, the first thing you want to do is complete the configuration of the software after the installation has been completed. Okay, so obviously we assume that the installation of the software has been completed already. Okay, but the software needs some configuring. So we'll go under Tools menu and go under Options. Then we will go under EDA tool options. Now you have to fill in this file path name under Mollusum Altera. I have it done already. So you're going to click on the browse icon. Then you're going to go under C, starting from C root. You go to Intel FPGA Lite, go to 18.1. Then go to mollusum_ASE. Then find the Win32 Aloam file and click on that. And then click on Select Folder. And that gives you a file path to the folder with the Mollusum executables. And then you click on OK. Now, this only has to be done once and for all. It's done with. Don't have to do that ever again. So now we can proceed onwards to doing the lab. So the first thing is to change hierarchy view to files view. We need to know which files are part of our project at any given time. So this is important. When you are following along with what I'm doing, don't leave out things, okay? And do exactly what I'm showing you to do. Otherwise, you will have big screw-ups. So we're going to start a new project with a new project wizard, which I'll click on here. And then we're going to do next. Now, we need a lab folder for our work files for our project. So we're going to complete this file path to our working folder, which they used to call directory, here. Okay, so it's going to be a left slash, and then capital L, and then AB1. Call it lab1. Don't call it lab_1. Don't call it lab_01. Call it lab1. Okay, otherwise you could have problems. All right? Now, I know it doesn't make sense, but later on you'll understand. Now, go lab. Call this lab1. Name your project. Now go next. Now, it doesn't have that lab1 folder made yet, so it needs permission to make it. Okay, we can start with an empty project. That's good. Go next. We don't need to add files yet. Go next. We don't have a board. We're not going to use the board this term. So just do next. Now, tool settings. This is critical. This is critical. Do not go carelessly over this. Get it right. Simulation is going to be Mollusum Altera. Not Mollusum, Mollusum Altera. Now, the language is going to be VHDL, not these others. VHDL. Make sure you get those two right. If you get it wrong, you're going to have big problems. Now, next. Now, see here, it's telling you that your simulation EDA tools are going to use Mollusum Altera with VHDL. Make sure it's saying that. Otherwise, you've got to back up and fix it. Then finish. Now it's going to open that project that we just made. Well, it's taking a long time. Oh, it's done. Okay, so we go look at our files list. There aren't any. Okay, so we're going to have to create some files. So the first thing we're going to create is a schematic, and we'll use File menu to do that. So go File, New block diagram schematic file. You see that? And then OK. So this is providing us with a blank canvas to draw our schematic on. And it's giving us some drawing tools above the schematic canvas. And it has given the name block1.bdf to our schematic. That's the name it's given. Now that name is not going to be appropriate. So we're going to have to change it. So we're going to do File, Save As. And save it as lab1.bdf, which it suggests. And then you see this check mark box where I'm pointing Add File to Current Project. We don't want to add that. We don't want schematics in the file list. Okay? So we can save it. Okay, so now I changed the name to lab1.bdf. Now, why is it got to be called lab1.bdf? Because the name has to match the name of the project for it to be a top-level entity, which you don't understand yet. but suffice it to say you need to do this. Okay, so we start drawing this. Now, what are you going to draw? Well, go look where you're supposed to draw. You're supposed to draw this. Start drawing this. Okay. So first thing you're going to need is input out markers. Go in, out, pin tool. You need input. You need output. I was going to need many outputs. Now, I'm going to zoom in. The way to zoom in is hold down the control key on your keyboard and roll the mouse wheel to make it bigger. Also, you can remove this IP catalog space. And we'll use this later. All right, so now we're going to get a device. Okay, so it's going to be under expanded library. It's going to be under primitives for logic. Okay, it's going to open that, and you can see all the different gates we got. You got 2 and 2 is 2 input and so forth. Now, we are going to need what? We're going to look. Going to need and, or, NAND, NOR. Okay, back to this. So go here. Now, a quick way to get it is to type in a name box, AND2. Okay, well, that's what I want, yeah. Okay, so place it on the canvas. Now, this is in repeat mode. It's going to keep repeating these. So I need to press escape on the keyboard to cancel repeat mode. So I got and. Now I need or. So OR2. OR2. There it is. I want that. Place it below. So I have and or. Now you can see I can highlight things and move them around. I'm moving them with the arrow key on the keyboard. That's called nudging. I can get everything lined up exactly the way I want. Now, so it's and or, NAND nor not. Okay. Next one is NAND2. So and or NAND. Now I need NOR. NOR2. And OR2. Now I need the NOT. So I type in NOT, N-O-T. All right. Now I'm going to go to this tools here and hover over. Now notice when I hover over this when it says orthogonal node tool. Okay? Now, the one next to it is a bus tool. Make sure you get the right one. If you get the bus tool by mistake, it won't work. So make sure you get the orthogonal node tool. Hover over it and read that it says orthogonal node tool. And click on it. Now your cursor goes into wiring mode. And you place your cursor at this input. Hold down the left mouse button with your finger and drag. Okay? Now I've got a nice clean line. You maybe got a line with a big fat circle in it. Okay? That means your hand wasn't steady enough and you actually have multiple lines where there should be one. So you would have to right click on this line and delete it in that case. If you had it right, you don't have to delete it. Now go back to here. Draw the line. Okay, so we got line drawing to do. Yeah, so I roll with the mouse wheel to move my downward in the schematic. Okay, I need wires for the outputs too. So there. How much wire? About that much. Okay, now escape. Escape goes back to select mode. Okay, so that the other way to do it is click on this arrow for selection tool. All right, now output. I need one here. Okay. I need an output here. Well, I missed. But I need one here. So I'm going to repeat mode. Okay, I will get it sooner or later. Okay, escape key. Now I'm going to line them up. Okay, I got it. Boy, it's difficult. Now, I'm going to start naming things. Once I got stuff named, I got it. I'm going to move this over. So this one, click on it. Then right click. Then properties. Then call it capital A. Now this one, right click, properties. Call it capital B. Okay, so complete all these. Rename the wires AB. Now I gotta name my outputs. So this is the output for AND. So we call Y underscore AND. I gotta stay with caps lock. Now, some students think, oh, don't need to do so much typing, just call it AND. That's going to cause a problem. It's going to conflict with a VHDL keyword named AND. So do it this way. Now, which is this one, the OR? No, Y underscore OR. And then we have Y underscore NAND. And or NAND NOR. Uh-oh, messed it up. So if you messed up, you can fix it. Then what? We're going to call this Y underscore INV, I guess, for inversion. All right, so is this good or not? Can zoom out. So that's correct, okay? Now, accept the pin name. I will put A, comma, space B. You must have a space after the comma, or you could mess up. All right? So A, comma, B. What did I have here? I got two of them. Actually, you can do this. You can have more than one name on a pin marker, all right? So this pin marker supplies inputs A, B, which get distributed to the different wires going to the inputs of the gates. Okay, so now you see this blue icon here on the upper left corner. You need to click that to save so you don't lose your work. Now, how do I know this is any good? Now, you could have a number of problems here. Now, you see this name here, instance, and then instance 2, then instance 3. Okay, now each gate has to have a unique instance name. If you have two of them with the same instance name, it's going to give an error. All right? So you can change an instance name by going properties and change the instance name here. See? Change it to something else. It doesn't matter what you call it. You could have, I could change this one to instance name 21. It would work, okay? Or instance name 5. The instance names have to be unique. So it'll be INST some number. That's one problem you can have. The other problem you could have is something's not really connected. Okay? So you can have something that looks like it's connected, but it's not really connected, okay? So you're going to have a problem with something not being connected, okay? Like things not being connected. That's another problem you can have. All right, now, this is something I can do that's optional. I can do analyze current file. Maybe it will tell me if I got it right or wrong. Now notice when I did that, this stop sign icon went up. And it's now doing something. Now, at the university, in the lab, we had Intel i7 processors. Don't have this at home necessarily. So we need to wait for the stop sign to go out. And we need to pay attention to this message window down below. Now notice that I can expand the message window this way. Now, it says what? It gives me an error already with a yellow triangle. Number of processors not being specified. And I have to make a statement in the .qsf file to set the number of parallel processors. Don't worry about that. Ignore that warning. So it was 0 errors, 1 warning. Now, if you want to focus on warnings, you can click on this yellow triangle. You can look at all warnings this way. You can look at errors this way. We don't have any. You can get more drawing space by condensing this window. Okay, so that's pretty good. It's looking good. Now, the simulation tools cannot work directly with this waveform. Or sorry, with this schematic. This schematic is useful for you to understand what you're doing, but the EDA tools cannot use it directly. So you have to convert this into VHDL code. All right, now if you knew how to write code in the VHDL language, you could bypass this schematic drawing step completely, which is what they do in the real world today. In the real world, they quit using schematics 10 or 20 years ago, and they went to writing VHDL code to describe circuits. So VHDL is a high-level language for describing circuits. Okay, so the two major languages in use are VHDL and Verilog. All right, so I need to convert this into VHDL code before I can go any further. So I will do that using File menu, Create Update, Submenu, Create HDL Design from Current Design. Okay, so HDL is high-level design language. Now, in the pop-up box, I will choose VHDL, and then OK. So it's converting this to VHDL code, which is what I needed in the first place. The schematic was just a sort of a crutch to get me to this code. Okay, that worked. Always look at a message window after the stop sign goes out, and cancel your compilation report and look at your message window. What happened? It was told to create a VHDL file. The creation of the VHDL file was successful. with 0 warnings. Okay, so what does it say? Created a VHDL file. I want to find that file. Now, this has a built-in file browser. Under File, Open. It's a file browser. And the VHDL code is called lab1.vhd. Click on that. Now, this one you want to add to the project. So click on this box down here, put a check mark to add it to the project, and then open it. I want to look at that code. Now, it should be in the files list. This is one of the critical files we need for our simulation. So it needs to be in the list. Now, if you have the BDF in that list, you got to remove it. Okay? So let's say you got a BDF in that list, you got to remove it. All right. You don't know how to remove it. Okay. Let me put it in there. Another way to put something in a project is project add current file to project. And it's in there. You cannot have two things with the same name in the files list. So we need the VHD for our simulation. Don't need the BDF. So click on it, right click, remove file from project. That's how I remove it. Okay, it accidentally got in there. Okay, so look at the VHD. So this is VHDL code. So it has this kind of a syntax. Entity lab1. Where did it get the name lab1? Well, it got it from the name of the file. So the file was named lab1.bdf. Okay, so that became the entity name. And that entity name will be top-level entity if it has the same name as the project name. Okay, now it has a port description. The port part tells you what goes in, what goes out. So it has A going in something called standard logic, B as an input, and then you have outputs Y AND, Y OR, Y NAND, Y NOR, Y inverse. So it starts by specifying what the inputs and outputs are. Then it has an architecture section for Lab 1. And between the begin and end here, it tells you how the outputs are related to the inputs. So the Y AND is assigned the A ANDed with B and ended by a semicolon. Y OR is assigned the B ORed with A and semicolon. The Y NAND is assigned the not of B ANDed with A and ended by semicolon, and so forth. So this is good. Now, if you had problems and you couldn't ever get your schematic working, you can edit this. See, you can erase stuff and change it, okay? So you could edit so you have this. As long as you have the right VHDL code, okay, maybe your NAND equation didn't come out right or something. You can fix it in here. But that's not a good idea. You know why? Because you're going to get graded on your schematic. And if your schematic is wrong, you could lose points. So the better thing would be to fix your schematic and then regenerate your VHDL code with file create update. Okay? All right, so look at this code. So this is a very wonderful VHDL code for our design. Now, the next thing we need is the test bench. All right? Now, before we can get the test bench, we need to compile this VHDL code. So we need to do a partial compile. There's 3 different levels of compiles represented by these blue triangles. And we need the one called Start Analysis and Synthesis. We don't need to do a full compile, which takes a long time, just this. So click on this icon, the blue triangle with the lightning above and the puddle below. Click on that. Stop sign goes up. Pay attention to the messages below. Well, it's taking a long time. Okay, so it's telling us it knows that Lab 1 is the top level hierarchy. And it tells us the analysis and the synthesis was successful with 0 errors and 1 warning. And the 1 warning is irrelevant. The number of processes is irrelevant. So we can cancel compilation report. And now what can happen to you is it could have discovered some problems with your schematic that you have to fix. Okay? So you have problems with the schematic, you got to fix them. So for example, you may have done this. You may have put a bus instead of a wire. Okay? That may cause a problem, right? So you got to go back and fix it. Okay? And then you have to create an update to get the VHDL code over again, and then you have to synthesize the code over again, okay, until you get no errors. That 1 warning was irrelevant. Okay, so now you can get a test bench, because by compiling this file, it has enough information to auto-generate a test bench template that you can fill in. So to get the test bench, you go to Processing menu, Start menu, and go Start Test Bench Template Writer. You see that? I'm going to leave it sitting there for a while so you can see it. So it's a matter of menu and submenu. Okay? Now, it's auto-generating a test bench template. Okay, so in terms of messages, it says that it has generated a VHDL test bench. And it's in this file path. That's where you would find it. Okay, and it's called lab1.vht. VHT is a test bench file. And there's 0 errors and 1 irrelevant warning. Okay, so let's find that test bench file. Let's open it up. File, open. Go to Simulation, double click. Under MolSim, double click. You can't see it. Now, this is called your file filter right here. Go to All Files. Now you can see it, Lab1 VHT. Now, add this one to the project with this. Okay, you could do it this way, or you could do it the other way. The other way is project, add current file to project. Okay, so these are the things you need for your simulation. You need VHDL code for the design. Let's look at that. And you need VHDL code for the test bench. See? So they both got the same name, right? But they're in different folders. All right. Now, how do I know this is a test bench? Because it has TST in the entity name. All right. So I go down here. What did I tell you? I said go to the always process and copy in this. So from your slides, copy in this. Control C to copy on the keyboard. Then go here. Oh, you already got to wait. Can erase this comment. So things in green starting with double slashes are comments, and they're not critical. Then Control V. Now I got 2 waits, so I can erase one of them. Okay, so I'm going to save that. So it's got a process. It will tell it how to go about creating the inputs for the waveforms. Okay, now, something here I have to do. It does not know what test bench to use unless I do Assignments menu, Settings. Then I want Settings for Simulation. So I have to set up this Settings for Simulation. So first I go to More EDA Netlist Writer Settings and make sure that Functional Simulation Netlist is turned on. That one. Okay, then okay. Next thing I got to do is hit the radio button for Compile Test Bench and then specify a test bench here. There is none yet. So go New. Then give it a name. LAB1. Oh, we got caps lock on. Okay, no, LAB1. What happened? I'll get cap locks on, but I didn't realize it. LAB1. Now, you see this browse icon? Go browse for that test bench. It's under simulation, under Mollisum. It's the VHT, not the back, the VHT. Okay, so it knows that that's the path to the test bench, and then you click add. Okay, then you click OK. Now what happened? It added that. Then you can say OK. So now it had lab 1 there where it didn't have that before. Okay, and then you say OK. So now it knows that this lab 1 VHT is my test bench that I want to use. So now I'm ready to go for simulation. So I go to Tools menu. Am I ready to go for simulation or not? Well, I've got VHDL code for design, VHDL code for the test bench. That's the two things I needed. All of this horsing around was just to get those two things. All right? So I'm ready to go to do the simulation. Now, the simulator's in the Tools menu. Run Simulation Tool, RTL Simulation. Now, what's going on down here? Now, the simulator is actually a third-party package created for Quartus by Mentor Graphics. And it uses a feature called Native Link to make it appear to be built in. So it's running the Native Link right now to get the simulator going. So when you see it talk about Native Link, that's what that means. So now I see an icon forming at the bottom. It turned into the Mollisum icon. So click that. Okay. Now we're going to go simulate menu. Well, I guess we have to wait for it. It's still setting stuff up. Go simulate, end simulation. There's already a simulation running. End that. Okay, now go File menu. New. New what? New project. Project name. Lab 1. Now, it's already figured out where to put that. Okay? So you don't have to worry about that. Now, okay. Now we have to add our files to our simulation. So click on Add Existing File and browse for it with Browse. Now, under Mollisum subfolder, you have the VHT. So open that. And OK. Now, so you got that. Now, what else you need? That's the test bench. You need the design code. So add existing file. Go up, up, Lab 1 VHD. Open that. Okay, so what have we got? Double click this. See, here it shows you. This is your test bench. You see? So that's your test bench. What about this? Well, that's your design code. It's got all the assignments for the outputs. Okay, now, you see you got question marks? That means they're not compiled. I'm going to compile them. So compile menu, compile all. 2 compiles, 0 filled with no errors in the message box at the bottom. So I can do my simulation now. So go to Simulate menu, Start Simulation. Now, you see this work folder? Click the plus sign to expand it. You see the test bench there? The Lab 1 VHD TST? Do you know why it's there? It's because you set it up in Assignments Settings for Simulation in Quartus. When you set that up, you created this entry in here. If that's missing, it means that you forgot to do your assignments settings for simulation and declare the Lab 1 VHT as your test bench. So you click on this and set your resolution to NS for nanoseconds, and then OK. right. So what you're going to do is click in this blue box here, dark blue box. Click on one of these, any one of them. Then go add to wave signals in region. So with signals in region, you click one, you get all of them. They get added to the legend part of the waveforms graph. So now you can do the simulation. Now, how long is the simulation going to run for? 1, 2, 3, 400 nanoseconds. So in this box here, put 400. See where I'm pointing? Near the top, in the middle. 400 nanoseconds. Now, to the left of it, click restart. Okay. Now, to the right of the 400 nanoseconds, hover over it, says run. There's your waveforms. But you got to fix the zoom level. So you're going to go zoom, right click, zoom full. And then you can move these vertical lines. And then you can, is it going to work or not? Oh, something you can do. If you want to, you can click on this, dock, undock. Where'd it go? Well, it's down here. Okay, so undocked it. Then I'm going to move this at the bottom. Okay, then I'm going to capture this for my lab report. So the way I capture it is I go to snipping tool. For you with Windows 10, it's going to be under what? It's going to be under, it's either accessories or, is it under accessories? It's going to be under accessories or Windows accessories or something. There's going to be a snipping tool, okay? So you bring up the snipping tool, and you have new for new snip. And make sure you snip everything needs to be snipped. Okay, so you need I need all these labels. Okay, and you need the time legend down there, okay? And there it is. That's your waveforms. So save it. Save it as. You can save it on the desktop temporarily. And you can rename it to L1 wave or something similar. Now you got your waveforms for your lab report. So you can close the snipping tool. Then you can redock this thing. And then you can close your simulator. Okay. All right. So you pretty well got it here. So what do you got to do? Go to the BDF. Okay, now get an appropriate zoom level with Control key on the keyboard and roll the mouse wheel. Then do a snip. Okay, and then save it as, you might as well put it on the desktop temporarily. What are you going to call that? Well, make up an appropriate name. Call it L1 SCH. Save. All right. And okay, where'd that go? So let me see if I got these things. So there's my ping from my L1 wave from a lab report. And here's my schematic. Okay, so I'm done, right? Okay, one thing I forgot to tell you. Before doing your synthesis with this blue triangle here, a good thing for safety is to right-click the Lab1 VHD and set as top-level entity. Okay, it knew it was top-level entity. Why? Because it was called Lab1, and that's the same name as the project name. So that's how it knew it was top-level entity. But you can overrule that with set as top-level entity, which we don't need to do, but we can do it anyway for safety. So that's something you can do for safety. So before doing your synthesis set it as top level entity. So that is really great. And the next step is to gather up these things, okay, these results, put them in the lab report, and write a nice report around these results. Okay, so I guess we're done.